So let's go ahead and do one that is from L's. Okay, so we have a cat and a mouse. The cat runs past the mouse and slides off the table. That is 2 meters high. It's really more of a shelf. And it lands, let's say, 3 meters away. What was the original velocity of the cat before it slid off the edge of the table? Okay, so both of these things, because they fly off the table at the same time, are treated in the y direction as both just falling straight down. Okay, the horizontal motion of the objects do not affect anything when it comes to the how the objects fall. There we go, much better. How the objects fall. Okay, so right now all we're going to talk about is how they fall straight down. And because their initial velocity in the y direction is 0, we can actually strike out that term from our equation. And that equation is just your standard displacement equation, which works for y or x. And actually, so we can tighten this up a little bit. There we go. So our equation for delta y is 1/2 a delta t squared. And we already know that our acceleration in the y direction is 9.8 meters per second squared. Okay? We know our delta y is this 2 meters because that's how far our cat and our mouse are going to fall. So we have 2 equals 1/2 9.8 multiplied by time squared. Now, isn't it negative 9.8? Yes, but which direction is the cat falling? The cat is falling down, so our delta y would also be negative if down is negative. Because these are both acting in the same direction, they have the same sign. So it really doesn't matter if they're positive or negative. That's just how they're going to be. So we can divide both sides by 1/2 times 9.8. And get rid of both. Over here we have 2 divided by 0.5 times 9.8, and that gives us a delta t squared of 0.408. Square root both sides, and we have a ran off the board. We have a delta t of 0.63 seconds. That's how long the objects are in the air. Okay. Now we're trying to figure out how fast the cat was moving when he left the table. If he's only in the air for 0.63 seconds, but in that time he travels 3 meters, that tells us enough for us to figure it out. We have a delta x of 3 meters, and that's going to be equal to our velocity in the x direction multiplied by our time. And this is because we can again start off with the same equation as we did over here for y, but our acceleration in the x direction is 0 because there's no horizontal gravity, and there's nothing to say that the cat actually accelerates or slows down while he's in the air, so we can just strike that straight off. Now we have 3 as our delta x. We don't know our Vx yet, but we do know our time is 0.63. If we divide both sides by 0.63, our Vx is equal to 4.696 meters per second. That's how fast the cat was running when he slid off the edge of the table.